and welcome to today's physics lecture, wherein we shall be discussing about cyclotron, which is obviously a very important invention in the science or in the field of physics. Now, the cyclotron was first designed in the year 1932 by Ernest Lawrence, which was later on improvised in design by a bachelor's degree student, M. Stanley Livingstone. Now, we shall be coming into the concepts of this cyclotron or its application a bit later, how it works. But first of all, we need to understand and we need to derive a very famous equation which is not only applicable for the case of cyclotron but also applicable for the satellite's rotation, right? So, as per the concepts of the lecture, if we do take, for example, as say over here, this is a vector V, and this vector, say for example, this is like the length, and this vector is V plus del V. Now say for example, this is in a circle and is rotating likewise, right? So obviously the change or this del V, this could be interpreted by this vector as del V. Then only you see the tail of this vector is on the head of this vector, which means on the vector addition, this will be V plus del V of this V and this del V, right? Now say for example, this degree of rotation is phi, which is indeed very, very small, right? In these circumstances, if we do wish to write the change of velocity or this del V divided by the original velocity, this will simply come out to be, what is del V over here? If we say for example denote as O, A and B, then obviously del V will be equals to AB, and over here this will be divided by R. So by cross multiplication we can get del V as equals to AB multiplied by V divided by R, right? Now as we know that if we do divide on both sides by del T, we will get the expression as del V divided by del T will be simply equals to AB multiplied by V divided by R, and over here del T, because we need to divide both sides with the same thing, right? Now what is basically del V divided by del T? It is the rate of change of velocity with respect to time. So simply this will be the acceleration or A, right? Will simply be equals to AB multiplied by V divided by R, and as we know that, say for example, the distance covered in a moment or in a time del T, we can write the expression like as the change of distance del T will simply be equals to V multiplied by the amount of time taken or del T. So over here this del T will simply be equals to del D divided by V, right? So it will be del D divided by V. This del T is replaced by this equation. Now del D means actually how much distance this has traveled, Obviously, this has traveled this much distance of AB, isn't it? So we will write it as AB multiplied by V divided by R multiplied by the del T or del D now be replaced by AB and this V, which is the denominator of the denominator, it shall go on the numerator side multiplied by V. So look over here, the AB and AB gets cancelled out. So actually the acceleration comes out to be V square divided by R, where R is the radius, as I said earlier, that this is like in a rotational motion or in rotational dynamics, right? Now if this is the acceleration, we know that force is basically equals to mass multiplied by acceleration, right? So we can say that the force is basically equals to mv square divided by r, while in this case we are seeing that something over in this point is rotating. Okay, for the time being, let us keep this derivation. And now we wish to focus on cyclotron. That, like, what is its construction, what is the principle on which it is working and how it is working. After that, the derivation, like what will be its time period, its frequency of the accelerator, and likewise. First of all, we need to understand that over here there are two D's. Now what is D? So for example, this one is D and this one is another D. Isn't it looking like capital D in English alphabet? Right? And that is the reason why these are known as D's. D-W-S. D's. Right? Now these D's, whatever the arrangement is over here, this is kept in vacuum. Right? These D's are actually separated by a certain distance, as you could see. Right? So this certain distance of separation between them is known as the gap. Right? Now, over here, if we do place something at this position, say for example, and we apply an oscillator over here. This is what? Oscillator. Now what is the work of an oscillator? First of all, this oscillator, it actually changes with time. It means that it actually changes. Say for example, at time 20 is equals to 0, this plate, it seems that this has got positive charge. But after say for 2 seconds, we will observe that this has got negative charge now and this has got positive charge. After again 2 seconds, we will see that the charges on both of them has changed. So after a regular time interval, the charges on them are changing. Now how could it be possible? It could be possible by the application of the electrostatic field. But with the help of the oscillator, we are able to change it. right? So this D is actually like this hollow thing. This what it could be shown as, like for example the 3D figure of the D shall be like this is like, okay, so this is a D. Over here inside this region, as you could see, anything can enter. So this is hollow on this part. So I can insert my hand and my fingertip can touch this point on the interior side. Likewise, both the D's are actually hollow. And there's an important concept that the electrostatic field inside a conductor is zero. So if something is inside it, the electrostatic force would not be able to be applied on it. Now, on the top over here, there will be, say, a north pole of a powerful electromagnet, and on the other side or the back side of this whiteboard there will be another electromagnet. The facing will be the south pole. So it will happen as such that these are two D's, and I have kept over here the north pole and likewise over here the south pole. So the application or the construction will look like this, right? Now say for example, if over here there is magnetic field, then obviously we could say likewise that the magnetic field are going into the plane of the paper or moving like away from the reader. And likewise this is applicable on the entire thing. Now here comes the concept. This small thing which is being kept over here, this are either protons or deuterons. The protons or the deuterons, we mean to say that they are positively charged particles, right? Kindly noted that over here we could either place a positively charged particle or a negative charged particle. The negative charged particle may be electron and the positive charged particle may be the protons or the deuterons, right? But as we know that like the neutron has got no charge in it, so we are not going to utilize it. Why? We are coming into the concept now. Let us say for example over here we have kept at this point a proton, and on the initial timing we saw that this is negative and this is positive. So this proton as being a positively charged particle, it would be attracted towards the negative side or the negative D, right? The velocity, initial velocity of the proton was basically at zero. But when it is getting attracted, which means that some acceleration is going to happen in it, right? And if some acceleration is going to happen in this thing, this will start move like this. And when this will move in a straight line. It may be noted again and again that in the gap, these protons or deuterons will move in a straight line. So this proton will move like this in a straight line. Now where it will go inside this D, it will find no electrostatic force over there. But Inside a hollow conductor, the magnetic field, this magnetic field present will work on it. So, as we know that if a charge is being kept, so over there, the Lorentz magnetic force will come into action or come into play, and this proton or deuteron now will start going in a circular motion, right? And whenever they come just at the end of the D so as to come outside, this oscillator now will just oppose this thing. Previously this was positive and this was negative. Now this will be positive and this will be negative. Now again, proton as being, or proton or deuteron as being positively charged particle, they will be attracted towards the negative D, and again on the other hand they will be repulsed by this D or the positive D. So whenever they will be attracted, say for example they were having a velocity equal to 2 meters per second, now they will be attracted with an acceleration, which means now their velocity will again increase. And if their velocity increases, within the gap they go in a straight line. After that, whenever again it will enter the D, it will find that there is no electrostatic force, but the magnetic force is present over there. So there will be a circular motion. But now, as you could see over here, the circular motion, it indicates this one, the radius has increased, right? And again when it will reach over here, it will see the oscillator to change it again. This as not like it, this as negative now, and this is positive. Proton or deuteron as being positively charged particle will again be attracted towards the negative in a straight line, and they will rotate again in a bigger semicircle. Again this oscillator will be changing the charges on the D's like this, again a bigger one, then again this will change, straight line, again a bigger circle, again this will be a straight line, and say for example there is over here, it will try, say for example we made over here a deflector plate, so this will directly come outside. Okay, so this thing what is being kept over here is a plate known as the deflector plate. There will be a small opening, and through the small opening it will go outside. Now as we know that a revolving particle, actually when, say for example I am revolving a keychain on my hand or on my fingers, suddenly if the keychain detaches from my finger, obviously it will not rotate and then fall. The position from where it has been detached, it will be flying tangentially. Likewise, this proton or deuteron will now fly off tangentially, and it might be possible that over here something is kept, and this thing is known as the target. So this cyclotron is being devised in as such that this particle or the protons or deuterons actually hit this target. Now why do we need to hit the target first of all? because we need to hit the target. So for example, it has been said like hit this pen. Obviously I need to hit this pen, which means that I need to apply some force on it. Now as we know that force is equal to mass multiplied by acceleration. The acceleration will be the same for either electron, proton or deuteron. But the mass of electron is very, very low or simply negligible. So the force acting on this target will be very low. This is the reason why we have chosen protons or deuterons. The deuterons obviously have got greater mass as compared to protons, right? So this is the reason why we have not chosen, or it is not actually desirable to take the electrons, because their mass is very, very low, right? But there are certain circumstances where the electrons are being chosen, okay, and there are certain limitations of this cyclotron.